All right, so today we're going to be looking at lesson 11.3, dealing with proving some of the triangle congruence criteria. Specifically, we're going to be proving the side, the side, angle, and the angle, side, angle. We're not going to look at angle, angle, side as much today. We'll deal with that in lesson 11.4. So we're going to start off with the side, congruences, and they give us two triangles. And they ask you in part A, what given information is marked in your figure? And as you can see, your sides are what are marked. So we have side AB, and it is marked as congruent to side DE. We also have side AC, and it is marked as congruent to DF. And then the other side that is marked as BC, congruent to side EF. So that's the given information that they mark. Then it asks, based on the definition of congruence, what do you need to do in order to show that the triangles are congruent? And so what we are wanting to do, we are wanting to take this triangle on the left and somehow transform it so that it gets mapped onto the triangle on the right. And so what we would need to show is that there is some sequence of rigid motions that would map triangle ABC onto triangle DEF. So somehow we would need to show, so whether that's a translation, a slide, a reflection, a flip, or a rotation, a turn, somehow, and maybe it may be a combination of those, somehow taking triangle ABC and transforming it so that it maps to triangle DEF. So it says it's given that AB is congruent to side DE. So what does that mean? That tells us there's some sequence of rigid motions that's going to map AB onto DE. And so now they want us to draw that figure that would map AB onto DE. But they give you a specific stipulation. We are not wanting to map C onto F. So we're not just wanting to make them so that the triangles are exactly on top of each other. What we are wanting to do is to map AB to DE and only have those two sides overlap. And so what you're going to basically do is take your triangle ABC and you're going to end up rotating it so that it maps, if I can get it to grab the green triangle, I'll just move it this way, so that it maps the triangles and share side AB and DE here. And so we're wanting to draw that figure. So we're going to keep E, F, and D where they are. And then when we take our triangle that was rotated, C is going to end up at the bottom, A is going to end up over here where D is, and then B is going to end up where E is. And so that would be for part D. That's what they're looking for. Then they ask you which points coincide in your drawing. Which points are on top of each other? Which points overlap? Points A and D? And points B and E. And then it asks which segments coincide, which ones overlap. And so the segments that overlap are segment AB and segment DE. And then the last part is to mark the line segments that we know are congruent. So that's going back to what we had labeled in part A, these three sets. So we know that AB is congruent to DE, and they share it, so they should be congruent. We know that AC is congruent to DF, and we know BC is congruent to EF. And so that's what they would want you to mark there. So now if you go ahead and go to the next page, G says, based on the figure, how is ED related to FC? So ED and FC are perpendicular. And that is because ED is the line of reflection here. It's the one that cuts our figure into the two congruent triangles. It is also going to produce these segments that are congruent. And they're not congruent to this one that has one mark. But this segment here is congruent to this segment here. And so what that means is that ED, so this is part G, ED is the perpendicular bisector of side FC. And that's because E is equidistant from F and C, so it must lie on the perpendicular bisector of FC by the perpendicular bisector theorem. Likewise, D must also lie on the perpendicular bisector of FC, which means that ED is the perpendicular bisector of FC. And so if you look at the next page here, it tells you the perpendicular bisector theorem. If you have a point that's on the perpendicular bisector, then it has to be equidistant from endpoints on the segment. So if this is my perpendicular bisector, this distance and this distance have to be the same thing. So now looking at H. Consider the reflection of triangle ABC across ED. What is the image of the triangle? Well, if we take this bottom triangle and we reflect it across ED, the image is going to be triangle DEF. So points A and B are fixed under this reflection. They're not going to move because they lie on the line of reflection. Point C is going to map to point F, since the line of reflection is the perpendicular bisector of FC. So that's what is going to be the image of triangle ABC. So now let's look at the next page. They tell you specifically we could rotate our triangle and then reflect it, which is what we were just looking at, and that's how we could show they are congruent. In the proof, was it important to know exactly which rigid motion mapped AB to DE? Did we need to specifically know that it was a rotation there? So no, it wasn't required that you know exactly which rigid motions would map them. However, it does help sometimes for you to be able to know exactly what it is. So although it's not necessary to specify exactly which rigid motions you would be using, if you know it, it can sometimes help you with your proof. It can show you that the rigid motion does exist. But if you can see it, you just can't exactly specify what it is, that's fine. So it's not required. You might consider it important, but it's not necessarily required. So then it asks, how is the definition of a reflection used in that proof? So the definition of a reflection across a line states that the reflection maps any point not on that line to another point, such that the segment that connects the pre-image point to its image point is going to be perpendicular to and bisected by the line of reflection. And so in what we were just looking at in our proof, ED was the line of reflection, and it is the perpendicular bisector of FC. And so that's how we were able to map C onto F, because we knew it was the perpendicular bisector. So that's how we used the definition of reflection. If you're wanting to look back more specifically at that concept, you would want to go in your book to page 116. And that talks about the perpendicular bisector dealing with your reflections. So that's page 116 in your SpringBoard book. So now we're going to look at the side angle side congruence criterion. So this time, what given information is marked in the figure? And yes, they are the same triangles. They kept them the same, but we're doing it in a different way this time because different information is marked. So this time they mark AB, and it is congruent to DE, and then AC is congruent to DF, and this time they mark angle A is congruent to angle D. And so the proof begins in the same way. Since we know that AB is congruent to DE, we have to be able to show some way to map AB onto DE. And they want us to draw the figure. And again, assume that it does not map point C to point F. So I'm going to have E, F, and D. And then I'm going to have B, C, and A. And then part C says to mark the line segments and angles that we know are congruent. So AB and DE, they share it, so they are congruent. AC and DF, and angle A and angle D. So something that they ask is if we reflected triangle ABC across the line of reflection ED, they want to know what is the image of AC. And so before we get there, I want to review these two angles are congruent. That means that ED must be the angle bisector of angle FDC, or you could call it angle FAC. But this angle here is going to have to be cut in half. That's what angle bisectors do, to produce two smaller congruent angles. So what is the image of AC? The image of it is going to be DF. And the reasoning is because ED is the angle bisector of this angle FDC. We know that since these angles are congruent, this side is going to end up having that side as its image. So since we're trying to show the congruency by a sequence of rigid motions, if we place the triangle so that one of the sides, ED and AB, are lined up, it's going to make that line of reflection, and it's going to make it easier to use reflection as one of the rigid motions in our sequence. And this is the way the book is choosing to work through it. That's not the only option, it's just the one that they chose to do. So now let's look at E. When we reflect triangle ABC across ED, can we conclude that the image of point C is point F? And yes, we can. The reasoning, since the image of AC is DF, like we just said in part D, the image of point C is going to have to lie on DF. And since AC and DF are the same length, since they're congruent, the image of point C must be the same distance from D as point F is. So that means that the image of point C is going to have to be point F. And so again, they tell you there's a sequence of rigid motions that's going to map the triangles to each other, causing them to be congruent. So now let's look at the next page. This time we're going to be looking at angle side angle. And so what given information is marked? We have side AB congruent to side DE, angle A congruent to angle D, and angle B congruent to angle E. And again, the proof begins the same way as the last two, and we're supposed to draw a figure that maps AB to DE, but does not map point C to point F. And so the figure that they're wanting you to draw looks something like this. And it again wants you to mark the line segments and angles that you know that are congruent based on what we just wrote in part A. So AB and DE are congruent, angle A and angle D are congruent, and angle B and angle E are congruent. Now if you look at my figure right now, this is not an appropriate representation of the given information. These two angles, B and E over here, are not the same as angle A and D. But as I have it marked right now, I'm saying that they are all four the same. So you need to make sure that one of your angle pairs has two arc marks. It doesn't matter which one. I could have put the two arc marks on A and D. But you just need to make sure that your congruent angles have the same number of arc marks and they don't have the same as any other pair of congruent angles. So now, looking at D, what is the image of AC? Well, the image of AC is DF because ED is the angle bisector of angle CDF. Likewise, the image of BC is EF, and that's because ED is the angle bisector of CEF. So very similar to what we were just looking at in the previous one. So when we reflect triangle ABC across ED, can we conclude that the image of point C is point F? And that is yes. Since the image of AC is DF, the image of point C must lie on DF. Then, since the image of BC is EF, the image of point C is also going to have to lie on EF. And the only point that lies on both DF and EF is point F. So that's how we know that the image of point C must be point F. So something to notice. Did you notice any sort of pattern in these first 5 questions? Hopefully so. They're all very similar type questions. Same triangles are just trying to get you to see that you, given different information, you would do slightly different things to prove that your triangles are congruent. So let's look at this example here. They give us a 2-column proof. And so Greg knows that point X is the midpoint of JK, so that's what they give us here. And he also measures to find that JL is congruent to KL. So there's our 2 given information. And we're wanting to prove that our triangles are congruent. So when you're working through these, I think it's helpful to mark the given information. So X is the midpoint, means that these 2 are going to be congruent. JL and KL are going to be congruent. So when I'm going to make my 2-column proof, I know for a fact those are congruent, and so I'm going to start with my given information. If X is the midpoint of JK, that means that these 2 segments, here and here, have to be congruent. JX is congruent to KX. The order does matter here. You can't say JX and XK. You have to say a specific order. If you're not sure what order, look here. JX, KX. They give it to you in the correct order in the prove statement. And so those are congruent by the definition of midpoint. Then they chose to put the other given in a separate step. I personally would have put both of them in step 1. Either way is fine. Then we know that LX is shared by both triangles. So that means that LX is going to be congruent to LX. And so they write congruence as reflexive. Personally, I'm going to label that as reflexive property. Either way works. That's just a personal preference there. And so then what is marked in our triangles are the 3 sides. And so by side, 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 we know that the triangles are congruent. So that's the example they give us. Now we're going to look at A, and it says, suppose that Greg knew instead that LX was perpendicular to JK, and suppose he made measurements to find that JX was congruent to KX. Could he prove that the triangles are congruent? If so, write the proof. If not, explain why not. So I'm going to come down here so that I have plenty of room. And I'm going to draw a new figure. So it's still using the same vertices, J, X, K, and L, but we're given different information. This time we are given that LX is perpendicular to JK, and we are given that JX is congruent to KX. And we are wanting to prove triangle JXL congruent to triangle KXL. That's what we're trying to prove, if we can. So if LX is perpendicular, that means that we have a right angle here. It also means that's a right angle, but we know we have a right angle because they're perpendicular. And then we know that JX and KX are congruent, and that's the given information. Is there any other information that we know about the two triangles? Well, they share side LX, so that means that the triangles have to have that side congruent to each other because they share it. And so yes, we are going to be able to prove that these triangles are congruent. We're going to be using side, angle, side. So when we're writing our proof for our statements and our reasons, I'm going to put both of my given in the first statement. But if you would prefer to split it out, you absolutely can. And so, if I know that these sides are perpendicular here, I can say that this angle is a right angle and this angle is a right angle. So, angle LXK and angle LXJ are right angles. And the reasoning there would be definition of perpendicular. So then, if I know that they're right angles, that means that the angles have to be congruent. So you could go into the fact that the measure of the angles equals 90 degrees and then set them equal to each other by substitution. Or we know that the angles are congruent by the right angle congruence theorem, which we have only talked about one other time this year. So if you would rather say step 3, the measure of the angle equals 90, the measure of this angle equals 90, and the reasoning be definition of right angle, and then set the angles equal to each other and use substitution, you could definitely do that. Or you can use the right angle congruence theorem. Either one would work. It would just require one extra step, but they would both be valid. So then the other thing that we added to our figure up here was that LX is congruent to LX. So I can say LX congruent to LX, and the reasoning would be the reflexive property. Anytime they share a side, we can say that they are congruent. And then step 5 is to say that the triangles are congruent. And the reasoning, as we already said, is side, angle, side. So that would be your proof for part A there. Now looking at part B. It says, suppose that Greg knew instead that LX bisected the angle. Could he prove to his boss that the triangles are congruent? So I'm going to draw the figure. And so we know that LX bisects angle JLK, which means that these angles are congruent. They don't give us any other information, but we can mark that these sides are congruent because they share them. But that's only two parts that are proven to be congruent. For a proof, you're going to have at least three parts. So we would need to either know another side or an angle pair in order to prove that they are congruent. So no, this one is not going to be able to happen. Since we only know two parts of the triangles can be proven congruent, we would need a third part. So now let's look at number 6. In the example, so they're talking about the one that they did. Are we able to prove that angle J is congruent to angle K? And yes, we can. We proved that the triangles were congruent. So since the triangles are congruent, the corresponding parts of the triangles are also going to be congruent. And J corresponds to K. They're both in the same position. And so since those are corresponding angles and the triangles are congruent, yes, we know that the angles have to be congruent. So now let's look at number 7. We want to draw a figure that would have two triangles. And it wants us to have given information that would allow us to prove that they're congruent by angle, side, angle. So this is two angles and a side. So I'm going to label my two angles first. And yes, I know my triangles don't look congruent, and that's okay. We're just trying to provide the given information that they asked for. This is a specific order, angle, side, angle. So that means that the side has to go in between the two angles. So on the left triangle, its only option is to go there, and on the right triangle, the only option is for it to go there. Your triangles wouldn't have to look exactly like that, but that's just how I chose to draw them. You just have to make sure the side included in between your two angles is the one that's marked as congruent. So now let's look at number 8. We're going to be writing a 2-column proof here. So we're going to start off with our statements and our reasons. Our very first statement is going to be our given information. So AD is congruent to CD. And that is part of our given. And they gave us another statement. And so we can put both of them in our first statement if we would like. And I think it's helpful to go ahead and mark that information. AD, CD, angle ABD, angle CDB. The other part that we can add is the side that they share. So we know that BD is congruent to BD. And the reasoning is the reflexive property. And therefore, we know that our triangles are congruent. And so we're really going to just copy exactly what they have there. ADB is going to be congruent to triangle CDB. And the reasoning is side, angle, side. And so that would be your proof for number 8. So now looking at number 9. We are given these 4 sides are congruent to each other. So when we go to write our 2-column proof, our first statement is going to be that PQ is congruent to QR, which is congruent to RS, which is congruent to SP. And that is our given. So I want to mark that on my figure. Now the next step, you're probably going to want to skip, but it's important that you make sure to list this out. we need to tell that PQ is congruent to RS. So PQ is congruent to RS. And likewise, we need to tell that QR is congruent to SP. And the reasoning there, we need to tell that we have a pair of sides that are congruent. This is saying we have 4 sides that are congruent, but we need to make sure that we are specifying we have 2 different pairs of sides that are congruent. And that would be using the transitive property. So transitive property. From there, we have one side that is shared. So PR is congruent to PR. And the reasoning there is reflexive property. I'm running out of room over here on the right side. And then after that, we can say that the triangles are congruent. So triangle PQR is congruent to triangle RSP. And the reasoning is by side, side, side. Now looking at number 10. I'm going to erase number 8 here. So we are going to start off with our angle K congruent to angle L and side KH congruent to LH. And that is our given information. So again, I think it helps just to mark it on your figure. And so that's what they give us. The other thing that we can mark is our vertical angles here. And so you don't want to say angle H. You need to make sure that you tell using 3 variables here. So angle GHK is congruent to angle. And now the order on this is going to matter. So we know H is going to go in the middle, but is it LJ or JL on either side of the H? So if you look, G and J are corresponding. So if I start with G, then J is going to go first on the next angle. And so it's going to be angle JHL. And that is by the vertical angle theorem. The vertical angles theorem. And then we know that our triangles are congruent. So triangle GKH is congruent to triangle JLH. And that is by angle, side, angle. So now let's look at number 11. We want to critique his proof. So he starts off correctly. The given information is given. This given information is given. And then when you look at step 3, I'm not given any other information, and in this paragraph here, there is not any other given information. It's not given in the figure. These angles may look like they're a right angle, but it's not given information. So steps 3 through 5 are not correct. So to fix it, instead of saying step 3 there, let's look at what information they gave us and mark it on our figure. So WX is congruent to YZ and ZW is congruent to XY. The other thing that we know is that this side is congruent because they share it. And so our step 3 should have been that ZX is congruent to ZX, and the reasoning is the reflexive property And then our step 4 is that the triangle ZWX is congruent to triangle XYZ. And that reasoning would be by side, side, side. And so that would be how you would want to prove that. Looking at number 12. They made a logo of an airline as shown. The designer made sure that AB bisects angle CAD. So CAD is being bisected by A. So that means that we have two angles that are congruent. This angle is congruent to that angle. Angle CAB is going to be congruent to angle DAB. Now something I want to point out. That is not saying that these two angles are congruent. It is not saying that it bisects CBD. So when you have an angle bisector, you want to make sure that you are only marking the one that is actually bisected and not both of the angles. If our triangles turn out to be congruent, then yes, that does mean that these two angles are congruent, but we don't know that until we have proven that the triangles are congruent. So we can't say that right now. So we know that these two angles are congruent. They also tell us that AC is congruent to AD. So we can mark those as congruent. And then we know AB is congruent to AB by the reflexive property. So is this enough information to tell that these are congruent? And if you look at this one triangle, we have a side, an angle, and a side. And so yes, by side, angle, side, we know that the triangles are congruent. So hopefully that helps you with lesson 11.3 and understanding your congruent triangles.